Hey guys, I want to talk about how we can calculate a determinant easier using EROs. So we're going to let A and B be two n by n matrices, and the deal is B is the result of performing an ERO on A. And your book has about 10 different properties of determinants. I'm just going to cherry pick the first three because I think that they're the most important for the things that we're going to be doing in this class. And the first one is, if you switch any two rows in A to get B, or columns, then the determinant sign flips. It goes from negative to being positive or vice versa. That is to say, if you switch two rows, flip a sign. The second property is, if you multiply a single row or column of A by a scalar, k, then the determinant of B is equal to k times the determinant of A. Or, I guess we could write the following, probably more important. The determinant of A is 1 over k times the determinant of B. So if you basically what this says is if you scale up A to get B, you have to scale the determinant of B back down by that same factor. So don't get too confused by this rule. It just means that you can factor out a value out of any row. So this is factor out a k value out of a single row of factor out k of it in a single row, I should say, in a single row. Okay, and then finally, and maybe this is the least intuitive rule of all, you can multiply any row by you want and add it to another row, and it will not actually change the determinant value. So if I do something like to go A is similar to B, but to get there, what I did was twice row 1 minus row 2 is my new row 2. That actually doesn't change the determinant at all. The determinant of A will be equal to the determinant of B. So how does all of this help us? Well, in a much larger situation, again, I'm only going to do a 3 by 3 here, to save time. But in a 4 by 4 or a 5 by 5 situation, this is how you can take the determinant quickly. You'll notice here that I've given you a matrix and it doesn't have any zero values in it. So I don't really have a preference for a row or column to expand along. But if I can use some of the three properties above and use EROs on this matrix to get zeros in a few positions, it will make the cofactor expansion on this determinant that much easier. So let's take a look at how that works. Yeah. Suppose we have A, where A is the rows 2, 1, 3, negative 1, 2, 5, 4, 4, 2, and we want to find the determinant of A. So we start by taking the determinant of A, and we get our vertical bars denoting that we're actually taking a determinant here. And we want to take this determinant, but there's no zero rows. So where do we start? Well, this being a 3 by 3, regular cofactor expansion won't take that long. But if this was a 4 by 4 or 5 by 5, we might want to do something similar to what I'm going to do here. So the first thing I might do is switch two rows. So let's see. Negative 1, 2, 5, 2, 1, 3, 4, 4, 2. And because of property 1, I am going to have to switch the sign of the determinant. Also notice that I'm using an equals sign here, not a tilde, because the tilde is for matrices, not determinants. These are scalar values, and they're equal to one another, as long as I adjust by a factor of negative 1. Now, let's see, if I use some other properties, what else can I do? I might be able to factor out a 2 out of the bottom row. This is negative, and then 2 times the determinant. Negative 1, 2, 5, 2, 1, 3, 2, 2, 1. Maybe I should do those in red. 2, 2, 1. Okay, great. So we've adjusted by a factor of 2. We scaled the row down, but we scaled the value of the determinant right back up. So balance, yeah? All right, now what we might do is something like this. This is -2. The top row is -1, 2, 5. And now I might start doing some real EROs where I do something like twice row 1 plus row 2 is my new row 2. And that'll give me -2 and 2 is 0. 2 times 2 is 4, plus 1 more is 5. 2 times 5 is 10, plus 3 is 13. And then 2 times row 1 plus row 3 is my new row 3. And we have -2 times plus 2, is 0. 2 times 2 is 4, plus 2 more is 6. And then twice 5 plus 1 is 11. Now, in that first step, I used property 1. In the second step, I used property 2, and that's why it changed by a factor of 2. And here I used property 3 a couple times, and it is unchanged with this step. This was scaled by 2, and this was flipped because we switched some rows. Okay, now what I can do is expand down this column, which now has a bunch of zeros in it, and this is equal to -2. If I use my plus, minus, plus checkerboard, I can see that I have these signs on my cofactors. So this will be a positive, not a positive 1, positive -1, times the associated 2 by 2 minor, which is 5, 13, 6, and 11. And then minus 0, plus 0. And I don't need to do the other two minors because they're times 0. And then what I actually have here is -2 times 55 minus 78, which is -46, and that's the value of the determinant. And I know it doesn't seem like it's that much faster in this case, but again, if that's 4 by 4 or 5 by 5, this is going to make your work a lot easier, especially when you're doing this by hand. Go ahead and give that a shot, folks, and see how it works out for you.